In this section, we will be talking about control charts. As you know, we use the statistical tool regression analysis with two entirely different approaches to forecasting. The first of these is causal forecasting, where we are explaining changes in one variable by another variable that seems to move with it. And the other is when we are using trend equations under time series. So once again, regression is the tool we're using, and all it does is it looks at relationships between two variables, or sometimes more than two variables, where one variable is what we are trying to forecast, sometimes called the dependent, sometimes called the predicted variable, and the other variable, sometimes more than one, would be what we are using to explain the differences, the changes in the variable we're interested in. And what we call this is sometimes the independent variable. It is also known as the explanatory variable or the predictor variable. So we have this tool, and sometimes when we use it with time t itself being the independent variable, putting on the x-axis on Excel the column on the left when you take a scatter plot. If that is time, then you're doing time series analysis and creating a line or a curve that explains the movements in the data and tries to forecast the upcoming values of that variable by using time as your explanatory variable. And in causal forecasts and causal models, you will be picking some other variable, as we have discussed earlier. This could be income, this could be the price of a product, the advertising budget, anything that seems relevant to whatever it is you're trying to forecast. Whichever forecasting approach you are using, if you are utilizing regression, you have to be reporting on your accuracy. You have to always report your accuracy measures, just like you would with your other forecasting tools that we have studied. So compute and report your MAD, your RMSE. You also have R-square, which is the significance of your model. It calculates the percentage of variation in the variable you're trying to forecast, how much of that is explained by your model. So always also look at and report your R-square. You want your MAD and RMSE to be as low as possible. You want your R-square to be as high as possible. Also, one more thing you should do, given that you have good R-square, MAD, RMSE values, before you relax and you can go ahead and use your regression model, you have to always plot your errors and at least visually check that your errors follow a random distribution without patterns. Forecasting only really works if the errors are random and normally distributed around your regression line. In this class, we're not going to check for normality, but at the very least, we will do a visual check for randomness by using control charts. Sometimes your control chart's upper and lower limits will be suggested by the context. Your boss will say, or your client will say, in forecasting, we do not want to make an error more than this much. That will be your upper and lower control limits for drawing your chart. If that is not externally given, you compute your root MSE, which is the square root of your mean squared error, and then you draw lines through 0 and plus and minus 2 RMSE values. So once those lines are drawn, you plot your errors in between them and sometimes outside of them, and you look for patterns visually. You check, for patterns. One thing you should look out for is an outlier or more than one outliers. Whenever, like what you're seeing in the upper right corner here, whenever an error exceeds your control limits, either it is higher than your upper control limit or it is lower than your lower control limit, that is a red flag. It will happen, especially if you're using plus minus 2 RMSE as your control limits. This will happen about 5% of the time if your data is normally distributed. So you should not stop using that tool, but you should try to see if you can explain why that very high or very low value took place, how likely it is to happen again. And if you are seeing a bunch of these or an increasing number of these, you should then consider changing maybe the tool that you're using, maybe throwing away some of your older data and redrawing a new regression only using fresher data. For instance, if you originally had 40 data points and you are seeing towards the end several outliers like this, several values exceeding your control limits, you would say throw away the first 10 data points and redraw your regression line, fit a new regression line to the newer 30 points. Probably the worst case scenario, the worst kind of control chart you can see is one in which most of your errors are above the zero line, much closer to your upper control limit, or below the zero line, much closer to your lower control limit. This is a case of bias. You will remember that you are calculating the tracking signal, which is a measure of bias, and if graphically you are seeing this, your tracking signal will also warn you that you have a tendency to systemically overestimate or systemically underestimate the variable in question, and you should not be using regression. You simply have to give up, you have to ask for help, you have to go look for another model, but you cannot under these conditions continue and use regression. Similarly, if the data's variability around your regression line is showing a marked pattern. Over here early on, you have errors close to zero, meaning your data is staying close to your regression line, but then that is spreading over time. And this is also another situation where you should simply drop regression even if your R-square looked good, your aggregate error analysis looked good. You are not going to be able to go ahead and use regression as your forecasting tool. There's a couple more scenarios you should watch for, in which case you don't really have to throw away regression as a tool, but you have to look to see if you need to change your assumptions a little bit. One thing is if your relationship is showing a nonlinear trend or a nonlinear relationship between the two causal variables, then you will see something like this. The errors kind of starting to go up, or the errors starting to go down, or perhaps going first up and then down, or first down and then up. And what this points at is a relationship between the two variables that does exist and is systematic, but is not linear. So this would be a good time to be trying to fit those polynomial, exponential, other forms of regression then align. And you should see something like this when you're working with your population file, for instance. Another example would be a case where this is maybe a little too pretty, but where your errors are moving up and down and up and down and above the zero line and below and above and below in a fairly rhythmic systemic pattern. And depending on how short those movements are, they might be seasonality. If they're somewhat longer, they might be cyclic. In this case, we would be talking, for instance, about your product sales changing through times of day or through the times of the year, for a seasonal example, or economic cycles over decades.